This is an example of where you might use the twos technique in an actual problem. So we have a problem, simplify. Now this problem might not be something that you've seen before, but the operations are not very hard. So we'll start into the operations. First off, in the numerator, there are some like terms, specifically the 3x and minus 2x. So that will equal just x. And then we also have minus 5 plus 7. That would be plus 2. In the denominator, we also have like terms. Here we have the 4x and the minus 3x. That would be x. And the 1 plus the 2 equals 3. Okay. Simple enough. Now, how do we continue? Some people might try that and get the answer of 2/3. It's tempting, but is it right? This is how we can check. So I'm going to let x equal 2. And I'm going to plug it in there, and then I'm going to plug it in there. Of course, I won't be able to plug anything in there, but then typically you'd plug it in before and after. So if I did this, I would get 2 plus 2 over 2 plus 3. And that would be 4 over 5. So that's what x plus 2 over x plus 3 would evaluate to if x equal 2. Well, that's supposed to equal 2/3. When I plug in x equals 2, although there's nothing to do with x equals 2, there's no x left over, the right side supposedly equals 2/3. Well, what I see out of this is 4/5 did not equal 2/3. So not equivalent. In other words, this operation, this step right here, didn't work because it gave us something that was not equivalent. So you can't cancel those x's. So therefore, looking at our final answer, this is multiple choice, we have the potential 2/3 answer and the x plus 2 over x plus 3, and our answer is clearly the x plus 3 out of those two choices. I haven't even looked at the other two choices. In fact, if you have multiple choice, one thing you can use this x equals 2 technique for is plug in x equals 2 initially and simplify, and then plug in x equals 2 into all four answers and see which one's the same. That's a lot of extra work for this was a pretty easy problem. So in actuality, you cannot cancel these two x's out. And I just proved it to you. So this is an example of how you might use the twos technique. When you're about to do a step and you're not sure if it's good, even though it might look a lot easier and not a lot nicer, it might even lead you to a multiple choice answer, you still want to be able to check, is this a good step? Okay, thank you.